fold, we give it as 0 value, comma, add. We take actually 3 values. So we'll try this particular thing. So this is, it is 0th value, right? So it is doing first, at very first instance, it is taking addition, that is 1 plus 2 is equal to 3 at partition 1. Similarly, this 1, 3 plus 4 plus 5. Takes at partition 2. Again, this is at first level. This is dividing is number 1. We'll say A. And this is B, which is at partition level, each partition. This is initialize. In C, it is actually combining. Here it is behaving differently. From partition 1, we have 3. Partition 1 plus 12 from partition 2. So total is 15. So this is the output. This is for 0. This is for this particular thing. What is this 0 and add. Okay, we'll try that. Sorry, 0. Yeah. See, this is 15. You see the diagram. This is normal one. So this holds good here. When 0 and add will holds good here. But when we use rdd.hold 1 comma add, this will behave differently actually. So same thing will happen, 1 plus 2 partition 1 and 3 plus 4 plus 5 is equal to, at partition 2 is 12, and then it will sum these things, which is actually 23 plus 12 is equal to 50. So later, after this, it will not stop across here when we have 1. It is actually adding them actually, these things. Initial value, this is total RDD plus initial value. It is multiplicating with 2 partitions into 1 plus initial value is 1. This is partition here. We'll just see that. We just give what is that, we just try to infer that. So I'll give you the formula. Number of partitions into 1 plus initial value. This is initial value. Initial value will be 1 always, because we are giving us 0. I mean here this changed to 1, right? So that is the initial value. So which is equal to, basically total RTD is 15 plus 2 into 1, that is 2 partitions into the initial value. This is initial value plus initial value, which is equal to 15. Sorry, 18. So this holds good here. So similarly, if we change number of partitions, it will vary. I'm giving us 4. So across thing is 15 for equation 4. 15 plus 4 plus 1 is equal to 20. It should be, but I know. Yeah, let's see. Let's do this. Yeah. So this is how it is actually doing inside. So this is the formula for that particular total fold value. And there is no 2, etc. Only 0 and 1. Is it clear? The same thing happens with aggregator. Is it clear about the fold thing?
Yeah,
this is the formula.
But we tried for 3, 4 like that also, right? For fold.
Yeah, you can. Yeah, you can try that.
Not that one. Fold inside the fold.
Sorry, inside fold 3 and all, no?
Yeah, I mean no. Different values. I think.
Yeah, but 0 and 1 are the most used cases.
But maybe some.
Yeah, different pattern it is taking actually.
Yeah. Okay.
I could find out this particular thing. 0 and 1 they are using actually. Why? Because this is basically 0 is with no partition level division. I mean, the data will be divided across partitions and aggregated across partitions across cluster. So that is 0. 1 is dividing across partitions and combining across cluster with number of partitions multiplied by number of partitions into the initial value. So if we give 4 here, let's see here, which is 4 to 7, 8. Is actually 25. So 4 into 2, we'll just see, this is 4, let it be 15 plus 4 into 2 plus 2 is equal to 4 to 8, 8 plus 2, 10, 25. So this is holds good here also. The same thing. The initial value is increased to 2. 4 to 8, 8 plus 2 is 10, 10 plus 15 is 25. So we'll just see like we'll increase the partition to 5, 5 into plus 5 plus 5 into 2 plus 2, which is equal to 5 to 10, 10 plus 2, 12, 12 plus 15 is 27. So I'll just increase this to 5. Yeah, our formula holds good here as well. Yeah, so this is the thing actually it is doing internally. But this we cannot find out actually. Like this was like I took some time for me, like because I was using only 1 and 2. 2 once I was using to find out this value, what it is doing internally. This is the formula for that. You can remember this formula. It is a good learning for me as well. Thanks, Naga, for bringing up this.
Thing like that, and
Yeah. No, to understanding that is different thing, but we should
yeah,
try that.
I tried to understand it, but I didn't get anything.
Yeah. But when I see the Spark this thing documentation also, I could not understand this. So finally, when I was trying with the different values, then I could find out the actual formula behind that.
Okay.
So you can explain this actually, what is internally doing to somebody, which because most of the people, most 90% of the people don't know about this. Maybe 95, more than 95% of people. So this is about hold. Similarly, aggregate will also work like this. It almost took some 3 to 4 hours to decode this.
మీరు అన్నెసరిగా స్పెండ్ చేశారండి అంటే ఇది ఇంటూ ఇది అంటే ఓకే
learning something is very good, right? It is learning new. So we'll just I will add this to the drive, so you could also have a look from this. So we'll start with the
అది కదా మీరు ఇంత ఇష్టపడ్డారు కదా దీనికి ఏమన్నా యూజర్ కేస్ చూసారండి మేబీ ఇలా యూజ్ చేసామని చెప్పుకోవడానికి
చూసాను బట్ ఏది కనిపించట్లేదు ఇప్పటికైతే. I will let you know because I don't see any use case where we have a particular addition where cross partitions and then multiplying with the number of partitions, and because there is no use case like I took some table maybe data frames ఏమైనా ఉందేమో I should try. RDD లో అయితే ఏమీ యూస్ కేస్ నాకు కనిపించట్లేదు. బికాజ్ ఎందుకు మల్టిప్లై చేస్తాం మనం నంబర్ ఆఫ్ పార్టీషన్ తో ఒక వాల్యూని.
అదేలేండి అంతేనా పార్టీషన్ తో మల్టిప్లై చేయాల్సిన అవసరం అయితే ఉండదు.
యా సో మన వాల్యూస్ చేంజ్ అయిపోతాయి టోటల్ ఇది వాల్యూ. సో దేర్ షుడ్ బి సమ్ యూస్ కేస్. సో అంటే ఫోల్డ్ అనేది తీసుకురావడానికి మేబీ జస్ట్ టు అండర్స్టాండ్ వాట్ ఇట్ ఈస్ డూయింగ్ అనేది, లేదా టు జస్ట్ టు make others at a data proofing అంటాం దీన్ని. అంటే డేటా వేరే వాళ్ళకి అర్థం కాకుండా ఉండడానికి దే ఆర్ ట్రైంగ్ టు డూ సమ్ ఇది.
Okay.
మేబీ ఫర్ దట్ దే ఆర్ యూజింగ్ ఫోల్డ్ అని మేబీ వన్ ఆఫ్ ద రీజన్స్. సెక్యూరిటీ రీజన్స్ కి అయితే అలా ఉండొచ్చు. ఎందుకంటే టోటల్ వాట్ ఈస్ ద టోటల్ నంబర్ విచ్ ఇస్ ఇన్ ద పార్టిషన్ అంటే మనం ఇప్పుడు 1 ఇచ్చుకుని ఏదైనా ఫోల్డ్ యూజ్ చేసామంటే it will give you different value, so you will know what is the value inside working, and if you know fold. So use case చూద్దాం. Let's start with the data frame. Krishna and Mohan, are you clear about the fold?
Yeah, Karthik.
Yes, Karthik.
So we'll move on to data frames today. So creating a data frames, we saw like SC, that is Spark Context or Parallelize, which is used to create RDDs. So now we see how the data frames are created in PySpark. Laga record అవుతుంది కదా?
అవుతుందండి.
Yeah, okay, great. So we have a data here. I have entered a data here. This is like the data which is basically employee data. This is the first is employee ID, second is employee height, employee weight in pounds, the third is employee height, and fourth is age, and fifth is gender, the columns. So you can see these two lists. In create data frame, if we are using two lists to bifurcate data and the column names. So the second list actually speaks about the column names. So in first list we have the data, in second list we have, this is tuples of data, list of tuples. Second thing is list of columns. So this is how we create 5 columns and 5 column names. Spark dot create data frame. So we have a display with Databricks. Actually, this works only in Databricks. To understand how, mainly it is looking for look and feel. Actually, displayed DF. We just now created a data frame. On top of that, we created a display that is displaying the data frame which we created. But in Spark, typically it works like this: df dot show. Df dot show is actually Spark's display. This is typical Spark display. So display is from display, in the bracket we give data frame, name of the data frame, to which will display the data of the data frame. That is limited to Databricks. The command display is only limited to data frame. So during development, we use most of these things like a display thing. When you wanted to see on any other system, then on PySpark, it is actually df.show. Show will give you the details. But do you remember what we were using in Pandas?
Head గాని tail గాని.
No. We had something to view entire thing. Something called info, df.info. So that was Pandas. So here the data frame is actually derived from Pandas data structures. So the Spark also, Spark data frames also behave same as data frames in Pandas, that is Python Pandas. So there is a slight difference. Only difference is in Pandas the data frames are mutable. Here it is immutable. That's the basic idea. Is it should not change in any time in Spark. That is the main idea which they made it as immutable. Data frame in Spark is immutable. Data frame in Python is mutable. So that is the major difference. So we just created the data frame. We'll see. We'll use some of the commands over it. So firstly, I'm using count. So here we are getting 7 as count. So can you tell me why it is giving 7 as count?
Yeah, we have 7 rows in the data frame.
Yeah, correct. So there are repetitive IDs also. So it is giving total count of the rows, number of rows in the data frame. So that is count. We can use count in different way also. We'll see in little bit of time. So there are different things attached to count. See, this is distinct. To find different values to find only the distinct values and then count them. So we use df.distinct.count. So we have 1, 2, 3, 4, 5. But why it is giving 6 here? Because we have only 5 distinct elements.
We have one duplicate, 3.
We have 5 also as duplicate.
The whole row is not duplicate.
Correct. That is the main reason it is fetching. So we can break out this particular count value across columns, like specific to I. So probably we'll see that in the next thing. I have added that also. So this is the command. We have this drop duplicates will actually drop the entire data, which is it will apply on entire thing. Drop duplicates will apply on entire thing. So it will delete whichever is completely duplicate. So if you have the entire row repetitive twice, so you can drop some of these. Here in our case, it is 3. Value of 3 is actually repeating twice. See, 124.1, 5.2, 124.1, 5.2, 23, 23, F. So that's the thing. It is actually showing distinct values as 6 in the count. So drop duplicates will drop number 3. So it is dropped number 3, and now we have 6 elements. Is it clear until here?
Yeah, Karthik.
మీరు డ్రాప్ చేసి మళ్ళీ సేమ్ డిఎఫ్ కే అసైన్ చేశారు కదండి.
Yeah, I created a new data frame with the same name, which is acceptable.
అంటే ఇప్పుడు డిఎఫ్ ఓవర్ రైట్ చేసినట్టు అంటారా?
Correct. This is overriding DF.
ఇది ఇమ్యూటబుల్ కాబట్టి మనం ఆపరేషన్ పెర్ఫామ్ చేసినా కూడా చేంజెస్ జరగట్లేదు, మనం మళ్ళీ అసైన్ చేయాలి.
Yeah. Operation చేసేసింది తర్వాత it will move that particular thing to DF again.
New. Okay.
మనం చాలా ఇలా ఓవర్ రైట్స్ చేస్తాం అనమాట. సేమ్ దీని మీద ఓవర్ రైట్, లైక్ కాలమ్ ఆన్ కాలమ్ థింగ్స్, చాలా ఆపరేషన్స్ చేస్తాం. సో దిస్ ఇస్ DF is equal to DF dot drop duplicates. Drop duplicates మనం చాలా ఎక్కువ యూజ్ చేస్తాం మన యూజ్ కేసెస్ లో, టు రిమూవ్ ద సేమ్ rows repeating twice, because machine learning లో సేమ్ థింగ్స్ రిపీట్ అవుతున్నాయంటే it will give us negative accuracy. So to avoid that, we'll use df.drop duplicates, and df.count is 6, that we know. We just dropped one of this. So now this is the main thing you should understand. Df drop duplicates, subset of the subset is equal to T for C in df.columns if T not equal to ID. Did you understand the subset part? Just see that. You should try to understand that. I will explain like how to read these things. This is completely like different from whatever we learned till now. Like maybe in your case also, like it may be Java, it may be SQL. It will completely shatter everything actually. These particular line of commands.
Actually, it is in the data frame. It is going each and every column. In each and every column, it is not checking the ID column. Means it is like that, Karthik.
Correct. But the thing is, this is a loop actually. This is a for loop.
Yeah, it is a loop actually. Yeah, I
Yeah.
mean inside
For
we.
loop, but acts differently. First and foremost thing, I was telling you, right, when we are discussing about RDD and all, we read from left to right, right? We usually, the program reads from left to right. Any program, any SQL command will read from left to right, correct?
Yeah.
But this particular lines will read from right to left. First, it is actually if C, that C is column, not equal to, that should not equal to ID. That is first command, it will execute. And then it will come to the for loop. So it has a condition before coming into the for loop. That is, if C not equal to ID, that is, it should not equal to the ID column. And then C will go for every other column. C is assigned to each and every column. It will check for duplicates. C for C in df.columns means it will go across, I mean it will iterate on each and every column to find this particular command, that is drop duplicate. Are you getting it?
Karthik, actually ఇక్కడ DF.
Go ahead.
Yeah, go ahead.
Yeah, ఇక్కడ df.columns ఉంది కదా. సో ఐ మీన్ మై అండర్స్టాండింగ్ ఎలా ఉందంటే df.columns ఫస్ట్ పిక్ చేసుకొని దెన్ దాంట్లో అగైన్ ఐ మీన్ ఈచ్ అండ్ ఎవ్రీ కాలమ్ కి వెళ్తుంది.
Correct.
But it is not picking the ID.
Yeah, but the first thing it will execute is df, I mean this C not equal to ID. That will the first. This is
ID
not
వదిలేసి
right to left.
అదే ఐడి కాలమ్ ని వదిలేసి మిగిలిన వాటిలో కనుక డూప్లికేట్స్ ఉంటే వాటిని డ్రాప్ చేయాలి.
డ్రాప్ చేయాలి అనే కమాండ్ ఇది. Because we know we have a ID column repetitive, that is 5. 5 should not be dropped, but based on other things it should drop. So మనకి ఇక్కడ ఏమవుతుంది, what we have data here, see this 4 and 1 are same, okay? Yeah, 1 and 4 are same, so we should not consider ID. ID is different. 1 and 4 are different. So it should not consider, while doing this, it should not consider the ID. It should only consider the data. And why I am avoiding only ID? Because IDs cannot be IDs, I mean same IDs cannot have duplicate things. Is it clear? Like same, I mean ID name undi, same pair undi, same weight, same data, same salary, annila unte, it is not acceptable. It should be some different, right? I mean name also, even first name, second name, everything cannot be same for every person. So that is the main idea. I'm dropping that particular thing. So this is doing like irrespective for, I mean every column it is checking, but it is avoiding to check in ID column. Is it clear?
Yeah, Karthik. Yeah.
See, this is actually which it checks. The output of this particular list is this. It will have a list of columns to be checked. So C for C in df.columns, it is actually giving this particular output. It first executes the ID. It is just like this. You can use this. Usually we use this particular thing, right? See, for C in df dot columns, if C not equal to ID, L dot append C.
So ఇక్కడ actually df dot columns అనేది మెయిన్ కదా మనకి.
Yeah, df dot columns is main.
ఇది టేబుల్ లాగా. I mean for example df dot columns అనేది నాకు ఒక టేబుల్.
ఆ టేబుల్ లో కాలమ్స్ యాక్సెస్ చేస్తున్నాం. That is a command. df dot columns is a command.
Yeah, okay. Okay.
C అనే దాన్ని మనం df dot column each and every column కి అసైన్ చేస్తున్నాం. It is iterating over that because we are using in a for loop. It will iterate over df dot column. How many columns ఉన్నాయో అన్ని columns లో చెక్ చేసుకుంటుంది duplicates ఉన్నాయా అని. It will avoid C not equal to ID, that is the ID column.
కార్తిక్, ఇప్పుడు ఐడి అనేది ఇప్పుడు సేమ్ ఇచ్చి దాన్ని జెండర్ ఉంది కదా, జెండర్ ని ఎఫ్ చేసి ఇప్పుడు సి నాట్ ఈక్వల్ టు జెండర్ అంటే ఇప్పుడు ఎట్లా ఉండిద్దో చూడండి ఒకసారి.
ఐడి ఈక్వల్ టు సేమ్ ఇచ్చి
ఐడి సేమ్ ఇచ్చేసేయండి. దెన్ జెండర్ ఉంది కదా, మేల్ ఉన్నదాన్ని ఫీమేల్ చేస్తే
ఓకే,
దెన్ ద కండిషన్ యూ కెన్ రైట్ సి నాట్ ఈక్వల్ టు జెండర్.
కానీ ఇక్కడ ఏమవుతుందంటే మెయిన్ థింగ్ ఇట్ విల్ వర్క్, డెఫినెట్లీ ఇట్ విల్ వర్క్. ద థింగ్ ఇస్ విల్ లూజ్ ద డేటా. ఎందుకంటే జెండర్ మీద మనము ఒక డూప్లికేట్స్ దీన్ని రన్ చేయకూడదు యాక్చువల్గా, బికాస్ there will be repetitive of genders that should not be considered as the main column to be avoided. Adi undali actually. So otherwise the data which we are doing, like for example same ante irrespective of the name and things, ID different undachu, height, age and idi same undi, male and female and different avute, adi chala jaragochu. So చాలా వాటిల్లో జరగవచ్చు అలాగా. సో వీఆర్ లూజింగ్ యాక్చువల్లీ డేటా. సో వీ షుడ్ నాట్ అప్లై దట్ ఆన్ దీస్ కాలమ్స్. అంటే మనం ఇవి అప్లై చేసేటప్పుడు టు నో ద థింగ్స్ వీ క్యాన్ ట్రై దిస్, బట్ వీ షుడ్ ఆల్సో లుక్ అట్ ఏ డేటా సైంటిస్ట్ ఆర్ డేటా ఇంజనీర్ పర్స్పెక్టివ్. యూ షుడ్ నాట్ లూజ్ యువర్ డేటా.
ఓకే, గాట్ ఇట్.
Yeah, so in that way we will not try multiple things where we are actually losing data. If we are trying to remove some duplicates, we should have a correct way of removing those. It should be logical. And these two things చూసుకుంటే మీకు ఎలా వర్క్ అవుతుంది అని అర్థం చేసుకోండి ఫస్ట్ థింగ్. అంటే వాట్ ఈస్ ద లూప్ డూయింగ్ దేర్ అని. మనం టిపికల్ గా నార్మల్ పైథాన్ లో రాసుకుంటే దీస్ ఆర్ లైక్ దిస్ ఇస్ ఎంటైర్ థింగ్. ఒక లిస్ట్ తీసుకొని ఆ లిస్ట్ లోకి ఇదేం చేస్తుందంటే ఈ పర్టికులర్ థింగ్, ఈ లిస్ట్ ఎల్ అనేది నేను లిస్ట్ క్రియేట్ చేసుకున్నాను. దిస్ ఇస్ హౌ వి రైట్ నార్మలీ ఫర్ సి ఇన్ df డాట్ కాలమ్స్ ఇఫ్ సి నాట్ ఈక్వల్ టు ఈక్వల్, అది ఆ పర్టికులర్ కాలమ్ ని అపెండ్ చేయాలి. ఎల్ డాట్ అపెండ్ సి అంటే లిస్ట్ కి అపెండ్ చేస్తున్నాం, ఫైనల్ గా ప్రింట్ చేస్తున్నాం. దీస్ టూ ఆర్ ఎగ్జిక్యూటింగ్ సి. సో యూ కెన్ సీ ద అవుట్పుట్స్. దిస్ ఇస్ ఎ లూప్ అండ్ దిస్ ఇస్ ఎ లూప్. వీ హ్యావ్ ద సేమ్ అవుట్పుట్. ఎలా వర్క్ అవుతుంది అన్నది మీకు అర్థం అవడానికి ఐ రోట్ ఏ ఫార్ లూప్ హియర్. ఇట్ ఈస్ జస్ట్ a Python for loop for our understanding how it is actually internally doing that. So ఈ particular for loop మీద I'm applying drop duplicates. Is it clear? అర్థం అవ్వకపోతే చెప్పండి. These two commands, I mean ఈ పర్టికులర్ కమాండ్ యూజ్ చేసాం కదా, దానికి ఈక్వలెంట్ ఫార్ లూప్ ఇలా ఉంటుంది యాక్చువల్గా. మనం ఇంతవరకు చూసుకున్న లూప్స్ ఏంటి, మనం ఏదైతే పైథాన్ లో నేర్చుకున్నామో లేదా జావా, ఎనీ లాంగ్వేజ్, ద టిపికల్ ఫార్ లూప్ ఈస్ దిస్. ఒక లిస్ట్ క్రియేట్ చేసుకుని ఆ లిస్ట్ లోకి మనం అపెండ్ చేస్తూ ఉంటాం బేస్డ్ ఆన్ అవర్ కండిషన్. అంటే ఇది is it clear? So if anybody has, please stop me. Anybody has any questions on this?
ఒకసారి మనం ఒకసారి ఎక్స్ప్రెషన్ చూపించరా?
Yeah.
ఈ ఎక్స్ప్రెషన్ కాదు పైన.
Yeah.
Okay, okay, got it.
Yeah, same expression అది. There's no difference. జస్ట్ దానికి అటాచ్ చేస్తున్నాం. డ్రాప్ డూప్లికేట్స్ అనేది జస్ట్ కాలమ్ లో మనం ఏమి ఇవ్వకుండా ఇచ్చేస్తే ఇట్ విల్ డ్రాప్ ద డ్రాప్ డూప్లికేట్స్, అంటే డూప్లికేట్స్ ఏదైతే ఉందో ఎంటైర్ రోలో ఇట్ విల్ డ్రాప్ దెమ్. కానీ సబ్సెట్ అనేది మనం డ్రాప్ డూప్లికేట్స్ మీద ఇంకొక సబ్ క్వెరీ ఇస్తున్నాం, దట్ ఈస్ అవర్ ఫార్ లూప్.
Okay.
Next is I'm trying to do a distinct count, which is actually like two things. One is oka command enti count anedi matram. We have one more command called count distinct. Two commands we have. Ante manam distinct dot count అని చూసుకున్నాం కదా, మనకి distinct count అనేది ఒకటి ఉంది, count distinct అనేది. So we'll see what it is actually. So here importing PySpark SQL functions. This is how to execute a SQL functions in PySpark anamata. Ante ivanni SQL functions we are executing correctly. So that is referred as import this particular thing. Import PySpark dot SQL dot functions. Our functions, entire functions of PySpark SQL functions, I am taking it as F. Then df dot aggregate. I am aggregating two things. One is f dot, that is SQL dot count, that is id, count on id alias count. Danni alias count ante the output of this particular thing will be as a count column. Second thing, f dot count distinct ids ni chestundi. Dot alias ante again it is creating a column called distinct. So if we execute this, for count we will get 5, for distinct we get 4, because we are applying on id file, id column. Id column actually has 6 elements, that is 1 2 3 4 5, 1 2 3 4 5 and 5 again. 3 we just removed, and the other thing is alias distinct is actually, it is taking 5 here because it is trying to remove the 1 5 actually. So we have only 1 2 3 4 5. If we see our df, this is our df. This is our df. So here, if you count these things, it is 6 elements, but 5 is repetitive here. We are giving as distinct among id, so it is replacing 5, one of the 5 here. So that's why we are getting 6 and 5. Is it clear? This function, we are actually doing here 3 operations. One is we are trying to create some columns which are aggregate columns. That is, inside aggregate function we are trying to use 2 counts. That is, one is normal count, one is count distinct, but on the same columns.
Alias is nothing but renaming the column name, right, Karthik?
Alias is nothing but renaming and kaadu, like adi idi lekapothe em isto teliyadu, but it will we can just try also, not a problem. We'll just see. I think it will give C dash something. Yeah, see, it is giving this thing. The same whichever it is inside that, it is giving this. So it can give like this. So we are creating an alias.
Okay, new display so.
Yeah, entire thing we are creating as alias. So this is the count, distinct and count, and also aggregate. So you should also always remember to pull these when you are using అంటే మనం ఏదైనా SQL operations చేస్తూ ఉంటే like this we usually use the PySpark SQL functions. You should call that and then only you can apply. Otherwise you should apply this PySpark.sql.functions in case of F here. F ఉంది కదా capital F, we should use the entire thing here, PySpark.sql.functions, and then you should continue count. This is a common coding we do for production also. It makes our life easier to read for anybody. If you are new to the project, if they are trying to read this code, they will easily understand actually. So that's why we use, if we use like PySpark.sql.functions, it is a like long code we are writing. If there is some spelling mistake in the this particular 3 words, right, we'll again lead into some problems, because we will be writing like maybe 50-60 lines of code in each script. So each transformation will have some 3 to 4 lines of code. So when we are writing so much of code, we try to make it simple. And for coding also, this will be really helpful. And this is also a standard coding thing actually. So you can also follow the same. But you should understand what F is actually. It is actually a function, that is PySpark.sql.functions it is. Count, distinct, everything is part of this particular functions. So here I am doing DF with column. With column we do like this is nothing but column operations we do. That is new ID we are creating. It is mono. This is actually creating a unique ID basically. So how we are creating a unique ID అనేది, it's a complicated transformation takes place behind this. I will just tell you like what it actually does. See, here we have 2 IDs basically. One is 5 and other is also 5. But to see them as a distinct one, we actually use this particular thing, monotonically increasing ID. This is a command we use for, we'll see, like I have tried to like, this will create based on its own algorithm actually. This is pre-created in Spark. So it actually takes some value at the first instant. It will assign for the first value, and then on that particular value it does some operation and create one more value, and again it will create on the current value, it will create one more value, it will assign on this value. It will keep on increasing actually. So the ID is which actually keeps on increasing. So this is how we create new unique IDs in Spark. This is a concept of how to create unique IDs in Spark basically. I will write that. I didn't write that. Otherwise you will get confused when you revisit this.
కార్తిక్ ఇప్పుడు ఇది క్రియేట్ అయిందా కార్తిక్, లేకపోతే ఆల్రెడీ డిఫాల్ట్ ఉంటుందా?
సారీ,
ఇప్పుడు ఈ న్యూ ఐడి అనే కాలం వచ్చింది కదా.
It created just now. See, it changed. When you apply again, it will change actually. The default value was last value, which will take something and it does some operations on it. Every time if you execute this, it will create new IDs for the same IDs actually. ఇది యూనిక్ ఐడీస్ యాక్చువల్లీ. అంటే దాని గురించి ఎక్కువ అర్థం చేసుకోవడం అవసరం లేదు. We use that to create unique IDs అంతే. So for help this particular thing, it will give the detailed thing that generates monotonically increasing 64-bit integer. So this is the main idea of how they created. So initially, for an example, consider a class of data frames which has 2 partitions, each with 3 records. This expression would return the value following IDs. So 0, 1, 2 are our partitions. 3 records unte, it will actually does this thing. It will take this and it will create these 2. And based on how many partitions it created in the data frame, everything it will take into consideration, and it will create on its own algorithm how it wanted to create.
Okay.
So it is like you need not worry about this because this particular thing added at 1.6 actually, Spark 1.6 the add chesaru. So it is still the same. They didn't do any changes for this. Just try to understand like what monotonically increasing ID. And how to create unique IDs and question is that you can just tell them. It is based on some logic, based on partitions and number of records, etc. So you need not worry about those things, how it is creating and all, because Spark haven't given that particular internal code to anybody. So yes, I think no person who is not part of this particular development will know how the functionality is created for monotonically increasing IDs. So just understand how to create unique IDs. And usually manaku Hadoop lo unique IDs అనేది లేదు యాక్చువల్గా టు క్రియేట్. స్పార్క్ లో దాన్ని ఉండాలి అనేది తీసుకొచ్చి పెట్టారు. సో దట్స్ ద అంటే based on some iteration it will create unique IDs. Just understand like how it creates అనేది. See, there are too many things actually. Current implementation puts partition ID తీసుకుని into the upper 31 bits and record number within each partition in the lower 32 bits. So 64-bit integers in తీసుకుని first 31 bits is actually the partition ID it is actually fetching. Second 33 bits it is actually fetching the record number within each partition. So the assumption is that the data frame has less than 1 billion partitions and each partition has less than 8 billion records. So if at all above 1 billion partitions, it will not apply, but 1 billion partitions are a huge number. We don't do so many partitions actually. So till that particular thing, it will apply. So just to understand that is manam ekkuga use cheyam, but if there is a real use case to create your unique ID on a data frame, you can probably try this. This is creating unique IDs in Spark on a data frame, which will not apply on hard disk. Is it clear? Just keep in touch with these commands and the new commands, and we never use actually. I never use this particular command till now. So, but you should know how to create a unique ID. If you get suddenly, if you get some new thing, for example, you want to start with the false proofing the data. Ante false proofing the data ante nothing but ఇప్పుడు ఇన్సూరెన్స్ కంపెనీ అయితే వర్క్ చేస్తున్నారు, you are false proofing the each and every row ID of the things. Each of the IDs it actually doing ఇది అనుకుంటే అంటే ఆ ఐడీస్ కస్టమర్ ఐడి ఇస్ నథింగ్ బట్ పాలసీ ఐడి మనం యూజువల్లీ యూజ్ చేస్తాము. సో ఆ ఐడీస్ ని ఫాల్స్ ప్రూఫ్ చేయడానికి అంటే వేరే వాళ్ళకి అంటే అదర్ డేటా సైంటిస్ట్ కానీ అదర్ ఇంజనీర్స్ కానీ తెలియకుండా ఉండాలి అంటే యూ క్యాన్ యూజ్ దిస్ పర్టికులర్ థింగ్ టు క్రియేట్ ద యూనిక్ ఐడీస్ ఫర్ దట్ పర్టికులర్ కాలమ్. అంటే మనం మిషన్ లెర్నింగ్ రన్ చేయడానికి మనం దీన్ని చేంజ్ చేసుకోవాలి అనుకుంటే యూ కెన్ ట్రై దిస్ అలాంటి యూస్ కేసెస్. Is it clear? or you need some more explanation on this, like where we actually how అనేది like it does internally, like we and based on partition ID and also record number within each partition, everything. So it actually bifurcates the 31 bits and 33 bits in the 64-bit integer. If somebody has some question?
No, Karthik. It's clear.
Yeah. So we have something more like handling missing data and percentage things. These things I think we'll start in tomorrow's class, basically, like because it should complete like the entire thing, entire flow has to go. So we'll keep it for tomorrow. This data, null, how to handle null, everything. It will start from handling missing data. So I'm just publishing this. So you can just import this particular thing and try to execute from here, like how to create a data frame, and you can create your own data frames as well. So try to work on till this counts, this thing counts, columns, drop duplicates, etc., and how a loop works and all. So we'll see more into these commands in tomorrow's class. It takes another 2 classes to understand the different operations of data frames. Then we'll start with the machine learning. So we'll take one use case and we'll run entire like data cleaning, whatever operations we did, right? Like removing drop duplicates. We'll have many things, such similar things. So we'll discuss about 3 basically. I will be using 3, that is decision trees, linear regression, random forest. So 3 different machine learning concepts with scikit-learn, how to import the scikit-learn. It is a pandas Python library. So we'll start with that from our Friday's class. So we'll have 2 days of solid time to see a flow of machine learning things in Saturday and Sunday's class. We'll see how quick we could understand the concepts in the we want to extend. I think we should extend little 2 or 3 classes. So probably around 10 classes we can complete the entire thing, machine learning as well as data frame. Will take another 2 classes definitely to understand different things like commands we have. Try to execute these things, because when you think about data frames in Python, we have different commands, and Spark, it is different commands, little bit advanced commands. So try to understand these things. Try executing these things multiple times. You will understand actually. So how to create a data frame and try to create some data frames with the data, not with the file, with the data actually. File we'll see more actually. We have Parquet, we have JSON, everything. We'll try to read JSON files, etc. Any questions? Whatever we discussed till
Santa Vista. They had even walked into the
Karthik, machine learning techniques, classification, clustering, regularization, optimization, are these all
under very high level thing? Classification ane dantlo malli we'll have random forest regression, I mean linear regression ivanni. Same clustering వీటిలో మళ్ళీ they will repeat. These are random forest, linear regression. These are actually machine learning algorithms. The concepts how we apply are these things: classification, clustering, and we have time series, etc. Then show them. I will tell you like which is classification, which is actually clustering, and I will tell you. And also regression is a separate thing. Under that we have logistic regression, linear regression, and something called there are very like maybe 20-30 different algorithms ఉంటాయి each and everything లో. బట్ మెయిన్ గా మనం వాడేది ఏంటంటే ర్యాండమ్ ఫారెస్ట్ అండ్ లినియర్ రిగ్రెషన్ చాలా ఎక్కువ వాడతాం మన పైస్పార్క్ దీంట్లో. ఫర్ బిల్డింగ్ అవర్ మోడల్స్ విల్ యూజ్ దీస్ టూ థింగ్స్. ఫర్ క్లాసిఫికేషన్ అనేది ఉంటది, సేమ్ థింగ్ క్లస్టరింగ్ అండ్ అదర్ ఆపరేషన్స్ ఉంటుంది. ఇట్ ఈస్ కంబైన్డ్ thing. I will tell you like wherever we are classifying, we are using classification algorithm, wherever we are using clustering algorithm. Clustering is nothing but putting into two different buckets. So when we do the sampling of the data, we use actually clustering, that is removing the entire data into two parts, that is train data, test data. So I will show you like when we apply these things in the machine learning things. Pretty easy. Like if you once you go through this particular flow at least 2 to 3 times, you will get it everything. Like end to end you will get it. Elagante kallu mundu vachestadi entire thing. How the data chudagane this is how you need to transform ane level ki vachestadi. But you should execute each and every step clearly. Ante meer okka step ni execute cheskuni artham cheskunte chalu. Machine learning will divide into 3 parts actually. One is data cleaning part, second is data training part, third is data testing part, that is execution part. There are 3 parts actually we does. So we'll see how those work. Once మనం data frames concepts అని complete చేసుకున్నాక we start that, and some of them will directly apply on the thing when we are cleaning the data, will directly apply there. Is it okay?
Okay. Karthik, want to discuss on the roles and responsibilities which I added in the CV.
Yeah.
Is it okay? We can discuss now.
And Mohan, నాకు మీది దొరికింది. I'm working on your profile. I will send across today. And Krishna, నాకు మీది మెయిల్ కనిపించట్లేదు.
కార్తీక్ నేను ఇంకా మీకు సెండ్ చేయలేదు. ఐ మేక్ ఇట్ టు హ్యాపెన్. నేను సెండ్ చేస్తాను మీకు. ఓకే అండి, పర్లేదులేండి, నాకు అంత అడావిడి ఏం లేదు. ఇమీడియట్ గా జస్ట్ డోంట్ నీడ్ టు జంప్. అండ్ ఎనీవే లెట్ మీ ట్రై టు సెండ్ యూ ఆల్సో సో దట్ విల్ ట్రై టు హ్యావ్ ఇట్ అట్లీస్ట్.
యా, మీ ప్రొఫైల్ మీద ఎలా మీరు రెస్పాన్సిబిలిటీస్ రోల్స్ మీవి డిపెండ్ అవుతాయి అనేది మీ దగ్గర పెట్టుకుంటే యూ కెన్ అప్లై ఎనీ టైమ్ కదా వెన్ యూ హ్యావ్ ఇంట్రెస్ట్ టు జంప్.
Correct. Yeah, that's true, Karthik. I'll send that one to you. So that,
yeah.